Europa, seen up close, is an icy world covered in a network of reddish cracks and bright plains. At first glance, it looks like a frozen billet ball orbiting Jupiter, but beneath the cracked ice shell lurks something astonishing. Think of all the water in Earth's oceans, now double it. That's how much liquid water scientists believe is hidden under Europa's surface. Where there's water, there could be life. No wonder this little moon has scientists so excited. Europa isn't just any moon, it's one of the most promising places in our solar system to search for alien life. Despite being only the size of Earth's moon, Europa has something Earth-like, a global ocean of liquid water beneath its frozen crust. This makes Europa extremely important to scientists. Water is a key ingredient for life as we know it, and Europa's ocean could hold twice as much water as Earth's oceans combined. That means if we ever do find life there, it wouldn't be shocking. It would have a vast habitat to thrive in. Beyond just the possibility of this moon containing life, Europa offers a natural laboratory for studying oceans of other worlds. It has a rocky interior and likely a metallic iron core, much like Earth. This means that Europa could have the right chemistry, not just water, but also the elements like carbon, nitrogen, and others cycling between its oceans and rocks, potentially providing the necessary ingredients for complex multicellular life to exist. And the wonders of Europa don't just stop at what's beneath the surface, but the surface itself. Europa's surface is as beautiful as it is bizarre. It's often said to be one of the smoothest surfaces of any solid object in the solar system. Unlike our moon or other rocky worlds, Europa has very few craters. Something has erased them over time. Instead, the surface is crisscrossed by long, dark streaks and cracks that give it a distinctive cracked ice appearance. These cracks stretch for hundreds of kilometers across the moon's face. Scientists think they formed because of Europa's icy crust being pulled and squeezed by this Jupiter's strong gravity as Europa orbits the massive planet. This constant tug of war, known as tidal flexing, stretches the ice and causes it to fracture and shift. In fact, some of the cracks match up on either side like a jigsaw puzzle, suggesting that pieces of the crust moved apart and fresh material from below filled the gaps. This means Europa's surface has been geologically active, renewing itself and staying relatively young. Beneath the surface, something dynamic must be happening, and it's likely the ocean is working in tandem with the heat from the interior. Now, you may be wondering, how do we even know that Europa has an ocean under its surface? Well, NASA's Galileo spacecraft in the 1990s gave the first big clue. Galileo detected a disturbance in Jupiter's magnetic field around Europa. The best explanation is that Europa has a layer of electrically conductive fluid under the ice. In other words, a vast salty ocean generating an induced magnetic field. This ocean could be 100 kilometers deep and envelop the whole moon. Imagine an entire world ocean sealed off by an ice ceiling, totally dark and isolated from any light, but kept in its liquid form due to the heat from the moon's interior. Europa's ice shell is thought to be many kilometers thick, but not so thick that the ocean is completely isolated. In fact, the reddish-brown material that streaks Europa's surface might be minerals or salts from the ocean below, forced up through the cracks. If so, this means that possibly there's an exchange happening. Material from the surface might be cycling into the ocean and vice versa. This is very exciting because it could bring chemicals that life needs from the surface down into the ocean, and possibly bring biosignatures up to where we can detect them. Europa's composition and active geology makes it a true sibling of the rocky planets, just one that happens to be frozen on the outside and wet on the inside. Even though no spacecraft has landed on Europa's surface yet, scientists keep finding new surprises by re-examining old data and using very powerful telescopes. One of the most thrilling discoveries in recent years has been the detection of water plumes. Essentially, these are geysers erupting through Europa's ice. In 2012 and again in 2016, astronomers using the Hubble Space Telescope spotted hints of these plumes shooting out into space. Then in 2018, researchers went back to Galileo's spacecraft data from 1997 and realized that the probe had likely flown through a plume without even knowing it. This was independent evidence that Europa's subsurface water can sometimes blast through upward cracks and vent into space. This is key. If water from the hidden ocean is escaping in plumes, a future spacecraft could potentially sample that water by flying through the geyser, like catching raindrops, and test it for signs of life, all without having to drill miles of ice. It's like Europa is giving us free samples from its oceans. Aside from plumes, new high resolution images have been shedding light on Europa's terrain. In September 2022, NASA's Juno spacecraft made a close flyby of Europa, the closest look since Galileo in 2000, and it captured stunning pictures of the surface. These images show rugged areas where blocks of ice have tilted and refrozen, and long curving ridges running across the landscape. Seeing these features up close after 2 decades helps scientists confirm that Europa's surface is indeed constantly reshaping. But the mysteries of Europa won't be solved by telescopes alone. That's why upcoming space missions are gearing up to explore this intriguing moon up close. The biggest mission in the works is NASA's Europa Clipper, which launched in October 2024 and is currently on its long journey to Jupiter. Europa's Clipper is specifically designed to study Europa. It is the first mission dedicated solely to investigating a moon's habitability. Europa's possibilities are truly endless. This moon will give us plenty to talk about for decades to come.